Hello, welcome back. Today we're going to do some quadratics review. We'll talk about things like zeros, parabolas, max and min, and projectile motion. I'm going to do two similar problems. I'll walk through the first one maybe more slowly, and then have you do the second one a little more on your own. If you don't have the Calculator X app or a graphing calculator, that's going to be okay because I provided screenshots of everything that you'll need to solve these. Let's look at the first question. The zeros of the function 2x squared minus 4x minus 6 are, so when they say zeros, they really mean the solutions. Zeros are your x values when y is 0. So there's a lot of values in this table, but what I'm really looking for are those times when y is 0. Do you see the two x values that happen when y is 0? Well, that happens here at -1, and it also happens here at 3. So my answer would be -1 and 3. You don't have to just look at the table. You can also check out the graph, especially when you have nice numbers like 3 and -1. These are integers. So we know that this point is the origin. That's at 0, 0. So I could just count 1, 2, 3, and that x value would be 3. And I can go backwards right there, and that would be when x is at -1. So let's look at another one. The zeros of the function 3x squared minus 3x minus 6 are, feel free to use the table or the graph to solve this. So let's say we use the table. I'm looking for the two values when y is 0. So that happens here. So my first answer would be -1, and my second answer would be 2. So I'm looking for -1 and 2. If you use the graph, this is 0, counting twice to the right, that's when x is 2, and 1 backwards, that's when x is -1. This one also talks about a parabola. They want to know how many real number solutions does 3x squared plus 2x plus 5 equals 0 have? And then we have to explain our answer. So they're looking for an amount and an explanation. Now, solutions are also zeros. So it means the same thing. It's when it's your x values when y is 0. Okay, so if I look in my table, it looks like at one point the numbers are going down, but then they start to go back up, so there's no 0 here in the table. And also, if you remember from our last questions, my zeros really happened on that x-axis. They happened here and here. And if I look at my graph, at no point does my parabola touch the x-axis. So when they say how many solutions, I'm going to say that there's no solutions. That would give me partial credit, and I'm going to explain, and I could say things like at no point does the graph touch the x-axis. You could say y never is 0 in the table, but I'm just going to say the graph doesn't touch the x-axis. Okay, so I'll have you try one on your own. How many real number solutions does 4x squared minus 6x plus 4 equals 0 have? And don't forget to explain your answer. So this is the exact same thing as the last one. Our graph doesn't touch the x-axis, and at no point do I see a 0 in the table here. So I will say no solutions. You could say for your explanation, the graph doesn't touch the x-axis. They have the term real number here because there are imaginary solutions, but you'll worry about that when you get to Algebra 2. Okay, a word problem. This is a real-life scenario. I know these look just like our parabolas that we've done before, but here they're trying to apply it to the real world here. All right, let's read. Let h of t equals negative 16t squared plus 64t plus 80 represent the height of an object above the ground after t seconds. What is the initial height of the rocket? Okay, so I guess the object would be a rocket here. So this is projectile motion. What goes up must come down kind of thing. They want the initial height. What does that word initial mean? You can look it up or tell me in your own words. So in math, initial means the start or the first. So the first height or the starting height. Think about when something first starts. Like the timer hasn't even started yet. So that means your time is going to be at 0. So if we're talking about seconds, I'm looking for 0 seconds. I'm given x and y in my table. X is going to be your time, and y is going to be your height. So I'm looking for when my time is at 0, and they're asking for the height at that point. So what's the height when x is 0? Well, that's 80. So when they say, what is the initial height? I'm going to say 80. They give you a unit here, I believe. Nope, they don't. I don't know. That's my bad. Let's say it's feet. And when they say justify your answer, justify means show, work, or explain. So you could, honestly, if this was a Regents question, you have your calculator, I would just honestly copy the table. And there you go. That's justified. Okay. I'll have you try this one on your own. Almost the same thing. What is the initial height of the rocket? And don't worry about justify since you can't actually write anything down. Okay, here's how you do this one. Initial means when the time is at 0. So x is time. It's 0 right there. So my initial height would be 10 feet. And if you wanted to justify it, you could explain it by saying at 10 feet, put a box around that. I guess that would be the initial height because that's when time equals 0, or time is 0. All right, I know this looks like a lot. I'm going to explain. So if this was a Regents question, you would really only see like this, but I put some help on the slide, and I put some screenshots since you might not have your calculator handy. So they want to know which quadratic function, that's just a parabola, one something like this or this, has the largest maximum. In your own words, what do you think a maximum is? A maximum is your highest point. So we're looking for which function has that highest point on top. So choices 1 and 3 are functions that you would type into your calculator. So let's look at choice 1. I've gone ahead and I've taken this and I just put it into a calculator, and I've provided the table and the graph. So in some cases, it doesn't really matter which one you use. So I'm just going to look for what even is the maximum of this function. Well, I could look at the table. What's the highest number that you see here? The highest number that we see is 6. Now, a maximum, which is right here, has a little curve to it. So what's going on with this repeating value here is that my maximum is going to be like, let's say here's 6 and here's 6. It's going to be a little bit above 6. So whenever you have two numbers that are the same in the middle, you can assume that your maximum or your minimum is like 0.5 more or less than what's repeating here. So I'm going to say for choice 1, the max is around 6.5. Okay. Let's look at choice 2. This is a little blurry, but I'm just going to help you out here. I'm looking for repeating numbers. I see that -3 repeats, 5 repeats, and then 9 repeats. So because I know when there's two numbers that are the same in the middle, it's going to be a little bit more. I can assume that my maximum is about 9.5. I don't really need those arrows there. And choice 3, I took this function, boop, put it right in the calculator, and I am looking for repeats. That clearly doesn't happen here, nothing repeats. So I can just look for the highest number. What's the highest number that you see there? That's 11, even though 11's not my maximum. And also on the graph, it's totally cut off because it only goes up to 10. I'm just going to note that it does go up to at least 11 and maybe beyond. I'm not totally sure, but that's the highest number that I see, so I'm just going to go with that for now. Hopefully I can get my answer just from that. And then choice 4, it's again a little bit blurry, but this is a number 1. They're telling you to count by ones. My maximum is here. So I have 1, 2, 3, 4, and 5. My max is right in between 4 and 5, so what do you think that would be? Right in between 4 and 5 is 4.5. So now that I have all of my maximums, I'm looking for the largest number here, and that would be 11. Even though that's not an exact maximum, I know it could be beyond that. Okay. So I'm going to have you try one on your own. It's a little clearer. So which one of these has the largest maximum? Here's how you do this one. I'm going to go choice by choice. So choice A, I'm going to count up to my maximum. It's 1, 2, 3, 4, 5, 6. So this max is 6. I don't know if that's my largest yet. I'm going to keep looking. And for this one, I find my repeats right there. It's right in between 5 and 5. So I'm going to assume 5.5. This one's the same one on the last slide. My max is right in between 4 and 5. So I'm going to assume 4.5. And this one, I mean, the highest number I see is 3. It's got 2 3s there, so I'm going to assume 3.5. So my largest one here would be choice A, which is 6. So we did largest maximum. Let's do smallest minimum. There's a little change in the process here, and I'll talk about why I have this number line. Okay, I'm looking for the smallest minimum. Let's just find our minimums, and then we'll talk about the smallest. Okay, so choice A, I know it's like teeny tiny, but these are all going by 1, so I'm just going to count down. So this is 0, that's -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So A would have a minimum of -10. Let's look at B. The smallest number here, also looking for the repeating numbers. -5 is right in the middle, so that would be my minimum. Choice C is just like choice A. I'm going to count 0, -1, -2, -3, -4. And then for choice D, it's a table. I'm looking for the repeating numbers, and I'll go for the one right in the middle, which would be -16. So which one of these is the smallest number? So hopefully you went with choice D. Now I know 16 itself is larger than all these other numbers if we took their absolute value, but when looking for the smallest negative number, we're actually going in the opposite direction. So we're not looking at the positive side, we're looking at the negative number side. So the bigger the negative number it is, the smaller it is, because your numbers are decreasing to the left. So these numbers are smaller and these numbers are larger to the right. Okay, let's have you try this one more on your own. I'm looking for the smallest minimum again, so try to find the minimum of each one and then choose the smallest, keeping in mind what happens with negative numbers. Here's how you do this one. Let's start with choice A. Here's my minimum. I'm going to count down: 0, -1, -2, -3, -4, -5, -6, -7, -8, -9. And then this one, 0, -1, -2, -3, -4, -5, -6, -7. The middle of my repeats here would be -6. And then this one, it's maybe not as clear to see, but that's your origin right there. And I would actually be counting up, and that would be +2. So if I'm looking for the smallest number, it's definitely not going to be a positive. So between these three numbers here, -9 is the smallest because -7 and -6 are to the right. The numbers get bigger. So choice A is my answer. Okay, this one's a little more simple. They're just asking for the solution set. So this is as if we have done the entire factoring process and we're just looking for your values of x. So when you have two factors that are equal to 0, each one gets their very own equals 0. So I have x plus 5 and x minus 6 equals 0. I do x plus 5 equals 0, x minus 6 equals 0. And to solve for x, I use inverse operations. What's the opposite of plus 5? It's minus 5 on both sides. Those cancel. I get x equals, and what's 0 minus 5? -5. So that's one of my answers. Same thing on this side. Opposite of minus 6 is plus 6 on both sides. Cancel those out. I get x equals 0 plus 6 is 6. So you might remember this life hack here. If your factor has a positive, your answer will be negative. If your factor has a negative, your answer will be positive. So I'm looking for -5 and positive 6. My answer is choice 2. Okay, try this one on your own. It's the same exact thing. Oh, actually, you know what? Before you do that, let me throw in those negative signs. So I have -a, -b, -a and positive b, positive a and negative b, and then both positive. Okay, that'll make things easier. What is the solution set of this equation? In order to do this, just got to switch those signs. Opposite of positive a is negative a. Opposite of positive b is negative b. So choice 1, where they're both negative. Okay, just looking at a graph here, there's two questions. The first one wants to know, what are the zeros of the function to the right? Zeros are where your graph touches the x-axis. That's your x, that's your y. So those two numbers would be -2 and 6. Axis of symmetry. Symmetry just means the middle, where it's the same on both sides. So in order to do that, I just draw a line, solid or dotted, down the middle of your parabola, and whatever x value it goes through, that will be part of your equation of your axis of symmetry. It always starts with x equal because it's an x value that you're looking at. Okay, let's have you do this one on your own. I know this is like a little blurry, so let's -1, that's 2, that's a 5, 5, that's a 6. Okay, so what are the zeros of the function to the right? So your zeros are right here and right here. That would be -1 and 5. What's your equation of your axis of symmetry? Symmetry means right down the middle, so I'm going to draw this down the middle. Oh, also goes through x equals 2. And that's it. Oops, a little unclear. That was, in fact, a 2. So good job today. Just let me know what you thought of this lesson, and I'll see you next time.